Week 7, Task 1, over arithmetic sequences. So remember, we talked in Week 6, Task 2, that a sequence is a list of numbers or objects in a special order. So something where the order matters. An arithmetic sequence is a sequence of numbers, so the difference between the consecutive terms is a constant. So this is not on your paper, but a formula for your arithmetic sequences, specifically these, which will be different in task 2, is a to the 0. So in this vocab, a to the 0 would be your starting term. Okay, so you can think like your y-intercept, or where you start, your first term, plus your d for difference times n, where n is like an x value, where you could plug any number in and get an answer. So d represents the common difference between the terms, and then a to the n is the nth term. So we just use n instead of x for sequences. So a to the 3 is the third term in a sequence. So that little number tells you the number or the term of that sequence. Remember, in the sequence, the order matters. So if it's a to the 3, it is the third term, meaning the first two terms come before and the fourth and on terms go after. So for example 1, we're going to complete that and then come back up and do those top things. For example 1, they want us to write the first 5 terms of an arithmetic sequence with a first term of 11, so that each of the consecutive terms is 4 more than the previous. So the first term is 11, and then they want you to take each term and make it 4 more than the previous. So we're going to take 11, we're going to add 4, so that next term would be 15. We're going to add 4 again, so the next term would be 19. Add 4 more to get 23, and then 4 more to finally have 27. So with these arithmetic terms, you are always adding or subtracting a number from the one before it. So I can't find the number 27 until I have the number before it to see what I'm adding 4 to, based on what we know so far. So for these, the third term in this sequence, this is 1, then 2, then 3. So the third term would be 19. And then D is that common difference, so it can be addition or subtraction. In this one, there are 4 more than, so your difference would be 4 or plus 4. So for example 2, find the common difference of the sequence below. So from 13 to 10, we are subtracting 3. From 10 to 7, we are subtracting 3. And 7 to 4, we are subtracting 3. So my common difference would be -3. To find the formula, you will use StatEdit. Now these are linear regressions, so whether you have a graphing calculator at home or the calculator app on your phone, you should be able to run these for a linreg for all of them. So we have terms 1, 2, 3, and 4. Those terms are 13, 10, 7, and 4. So this part is what you have to fill in. Whatever your sequences will be your y values. So I will go to StatEdit. My terms are 1, 2, 3, and 4. I have the first, second, third, and fourth terms. So 13, 10, 7, and 4 are those terms. So I do stat calc linreg. And my formula is going to be -3n plus 16. Notice this plus 16 is not listed anywhere in my sequence, because remember, your formula is your starting value, your a to the 0, so if your original term. This is term a to the 1, so if you don't want to use a calculator, you would need to work backwards and there's a number, you take away 3 and you have 13, which means you had to start with 16. That's the number that goes here. But again, use that linreg for these problems to figure this number out. Then it tells us we can continue the sequence or plug into the formula to find a to the 7. Right now we have a to the 4, so we would need to keep subtracting 3, or we can plug in 7 for an n value. No matter what device you have, whether it's a graphing calculator or a phone calculator, you could figure this out by typing that in to get -5. For example 3, they are giving us a sequence can be generated using a to the n for a n minus 1 plus 5, where a to the 1 is 7. What are the first 4 terms of this sequence? So here we have our starting. Our a to the 1 is 7. And then they are giving us our difference. So we are going to add 5 to get 12, add 5 to get 17, and add 5 to get 22. So that's one that you can do by hand. For example 4, they've asked us to write the recursive formula or write the formula for the nth term of the sequence given below. So before we can write the formula, we have to find the difference. So from 8 to 8.5, we are adding 0.5, adding 0.5, adding 0.5, and adding 0.5. It would not be arithmetic if you do not add the same things or subtract the same things every time. So that common difference is going to be 0.5. My formula is going to be 0.5 in, and then I have to figure out what this number is going to be. So again, you have two options. You can work backwards by taking 8 and subtracting 0.5, or put it into stat edit. So my first term is 8, my second term 8.5, third term 9, 9.5, and 10. So I know the first 5 terms. Remember, your formula is your difference times n plus your starting term. We don't have our a to the 0. We have a to the 1, but not a to the 0. So I'm going to do stat calc 4, or like I said, 8 minus 0.5, and you would get 7.5. So no matter which way you choose to do it, you should be able to see your answers. Example 5, asks us for the 100th term of the sequence. So for this, if I'm going to work without a calculator, I'm going to have to do this a lot. Or remember, I can put this into stat edit. So my first term is 5, second term 8, third term 11, fourth term 14, and fifth term 17. Now, on your assessment, anything where you would need a calculator, we are going to provide you either with how you should put it into the calculator or what you get out of the calculator. So keep in mind that these are terms 1 through 5, and then my terms are listed here. So see how I have it set up in my calculator. I will tell you there is one on your assessment where it asks you if it is set up correctly in the calculator, so make sure you know how to set them up. And then stat calc 4, there is one where you are given the printout like this and you have to find a term. So I would have a to the n plus b, so 3n plus 2. They want the 100th term, so 3 times 100 is 300 plus 2 is 302. And again, you can do that with any calculator that you have at your disposal, whether it is a phone calculator or a fancy one. Write the first 5 terms if a to the 1 is 2 and my difference is -7. So my first term, a to the 1 is 2. I'm going to subtract 7 for a2, and they want the first 5 terms, so 3, 4, 5. So 5 minus 7 is -12, minus 7 is -19, minus 7 is -26. So those would be my first 5 terms. I'm starting here and I am taking away or adding if it was positive, but this one is a negative, so I'm taking that away every time. Example 7 wants us to write the rule or equation for the given information. So in order for me to write the rule, I either need 2 terms to put into the calculator or I need to work backwards. So I'm going to show you how to work backwards on this one. So with this one, I know a to the 1 is 2. My difference is 3. So they took a number here, they added 3, and they came up with 2. So when you work backwards, you literally work backwards. You do the opposite. So I'm going to take 2 and subtract 3 to find my starting number. So it is my difference times n plus my starting number for that rule. Now for part B, two ways to do this. Again, you could work backwards to find your difference and then go backwards, or put it into the calculator. So a to the 1 is 2, a to the 2 is 9. I could work backwards, or if I wanted to, I can put little number and then my big number, my term. So my first term is 2, my second term is 9. In the calculator, I would plug it in like so. And this is one you want to make sure you star for that quick check. So notice little number, big number, little number, big number. So when I do stat calc 4, my equation is 7n minus 5.